Hi, my name is Nishant Balapur. I'm here to present a work that was co-authored by Shubham Agarwal, done during my time as an undergraduate at UIUC. This is a joint work between Zhao Han at UIUC and Di Yang at Stanford. So to give some background, our work is concerning dynamic topic models, which are used to explore the evolution of topics in temporal corpora. So the popular approach for dynamic topic models have been unsupervised. They're typically more useful than supervised topic models since they don't need a labeled document collection. And these are typically based on LDA or some embedding-based method. Like some example tasks could include how specific scientific fields change over time. However, we find some limitations of existing DTMs. The first, being highlighted in blue, is that DTMs may find uninformative terms that are repetitive across time steps. They also might find terms that overlap with different topics, such as we see here results in models, which could refer to either NLP or neural networks. So, to address this issue, we propose a new task called Discriminative Dynamic Topic Discovery. Our input for this task is a user-specified set of seeds and a timestamp document collection, and we hope to extract a sequence of terms that captures the evolution of each seed. So for example, if our seed was machine learning, we might expect things like CNNs and RNNs in the earlier time step, followed by T5 and GPT-3 in the more recent time steps. So our solution for this task is called DynaMiTE, which aims to dynamically mine topics with category seeds. Given a timestamp document collection as an input, along with some user preferences represented as category seeds, we combine 3 scores, which I'll mention on the next slide. And using these scores, we mine candidate terms one at a time for a topic evolution. And since we mine these one at a time in an iterative fashion, we use the information at each epoch of our framework to update different aspects of the DynaMiTE model. So our overall methodology going into the score is that they prioritize 3 different things. First, we have a semantic similarity score, which makes sure candidate terms are similar to a user's preferences. To do this, we develop a discriminative dynamic embedding space, which improves upon Word2Vec and jointly captures the evolution of topics and user preferences. Basically, prioritizing this score will find terms that are more likely to be related to the user's preferences. Next, we have a category indicative score, and this eliminates the problem of overlapping terms that we saw in the intro example. So to do this, we follow the intuition that terms for seeds that we want will be discussed in documents that talk about the seed. So if we want to find disasters, we should be looking in documents that talk about disasters. The third and final score is a time indicative score, which eliminates the problem in the intro that we saw of repetitive and generic terms across different time steps. So to do this, we develop a new burst TF-IDF score, which quantifies how unique a certain candidate term is to the current time step. So using our DynaMiTE framework, we tested on 3 different domains across a bunch of different state-of-the-art baselines. We find that DynaMiTE performs well in NPMI and MAC, which are the typical existing metrics for evaluating the non-dynamic aspect of topic evolutions. But we also wanted to evaluate the temporal quality of our evolutions. So to do this, we introduce a new human evaluation setup where we ask annotators to try and order shuffled topic evolutions. And we find that DynaMiTE excels both in the traditional metrics as well as our new setup. Here I also have some qualitative results that I wanted to point out. So with our DynaMiTE framework, I have highlighted here the example of disaster, which was in one of our datasets. We find that DynaMiTE is able to extract very informative terms like Hurricane Hugo and Iraqi invasion of Kuwait, which are very uniquely related to the term disaster. And further, if you were to look up when Hurricane Hugo happened and when Iraq invaded Kuwait, you would find that they happened in these corresponding time steps. So this indicates that DynaMiTE is able to effectively mine terms that are discriminatively relevant to the category seed, as well as the time step, producing very informative topic evolutions. When we compare this to the existing baselines, we find that, for example, BERT topic finds words like recent experiences or coordinator, which aren't very informative or relevant to the seed disaster, and something like dynamic word topic at the bottom finds catastrophe at each time step, which are not very informative to the user if they want to see how disasters have actually evolved. So that's everything that we wanted to cover in our slides, or in this video. So overall, as a conclusion, we studied the task of discrete dynamic topic discovery and developed DynaMiTE, which is an iterative framework and that combines scores from different dimensions to solve our task. We also designed a new human evaluation experiment to evaluate the quality of topic evolutions, and we find that DynaMiTE produces very high quality topic evolutions. Yeah. So that's everything, and if you want to check out more, please take a look at our paper. Thank you.